Okay, so I'm going to look at some of our homework problems from this week to give you a little bit of help. The first one here, we have a population mean of 136 and a standard deviation of 25. Find the mean and standard deviation for the sampling distribution with a sample size of 56. Well, for the population mean, that's going to be easy, right? If I want, let's clear this. The mean of the population, or the sampling distribution, just equals the mean of the population. That's our rule number one for central limit theorem. So in this case, the mean of our x bars, our sampling distribution, is just 136. Okay. For standard deviation, it's a little bit different. We saw in class, standard deviation gets smaller as sample size gets bigger. So I have a population standard deviation of 25. That's going to be smaller. I have to divide that by the square root of my sample size, which is 56. So I'm going to have 25 divided by root 56. And I get 3.341 if I go to 3 decimal places. And like we said, this one's not going to change, it's just 136. Okay. I want to jump to question number 8 next. Okay. Another central limit theorem deal. So I have the population here. Population mean is 16.9. So I look at these three graphs, they all have a mean of 16.9. So they could all be correct in that regard. Then for standard deviation, I see that I have 12.4 for the population. Any sampling distribution here, the sample size is 100. Okay, so the standard deviation is going to have to get smaller. These two still have the same population standard deviation, so they have to be wrong. So the correct answer has to be 1.24. Where did they get that? Well, they took the 12.4, right? The population standard deviation was 12.4, and they divided by the square root of 100. So they had 12.4 divided by 10. That's 1.24. Okay, so that's what our sampling distribution. So this has to be the right graph, and of course, even though the population is not normal shaped, that doesn't have a normal shape distribution. If this sample size is over 30, then we're good to assume that we have a normal shaped sampling distribution. So this would live at 16.9, no change there. This is 1.24, and this is what I kept messing up here. This is A. They put those letters out of order. Graph A, I want this one, and it approximates a normal curve. Let me jump to number 10. I think that's a little bit different than those. All right, so in this situation, we want the mean and standard deviation of the population, okay? And then we're going to list all samples with replacement of the given size from the population and find the mean of each. Find the mean and standard deviation of the sampling distribution and compare them with the mean and standard deviation of the population, okay? So they give us the word counts for 5 different essays, right? 506, 631, 549, 608, and 585. So we want to use a sample size of 2. So the population mean, that's going to be simple. We're just going to add all these up and divide. They give us to us in StatCrunch. You could put it in StatCrunch, or we could just use our calculator. So I have stat and edit in my calculator. Maybe clear the list that you have in there. So I have my 5 numbers in my list. I go to stat, calculate, one variable stats, and if you have a frequency list there, we don't want it there. Depending on your calculator, you can either leave that blank or put it as a 1. I'm going to leave it blank and see what happens. Yep, okay. So I just want to do, so if you have a different calculator, oops. So I may have a calculator that just puts one variable stats on my screen. One variable stats L1. That's all I'm going to do. I don't want any comma or any frequency lists. So my population mean is 575.8. My population standard deviation is 44.179. We'll use that. Okay, so 575.8. Okay, and we're going to have several steps. And the standard deviation of the population also is right there, 44.179. How many decimal places they want? 2. So I think that would be 44.18 to 2 decimal places. Okay. So now here we want to look at all samples of size 2 with correct accompanying means. So this is going to take a little while, but they're saying use a sample size of 2. So I have 1, 2, 3, 4, 5 numbers to choose from, and sample sizes of 2. So we want to find the mean and standard deviation of the population, and then we want all samples with replacement. Okay, so with replacement means that I could get the same number twice. So these guys here, where I have the same number twice, would be possible. Okay, let me explain how I did this one, because it would take you a few minutes probably to trek through this, but they're kind of not real organized. What I did was I started with 506, and then I took 506 and paired it with every other number. So I took 506 plus 639 and divided by 2. And then I looked down here to find that 506 and 631, add them, divide by 2, and that is the average that you would get. Then I took 506 plus 549, and I divided by 2. Okay, 506 plus 549, divide by 2, and I found this to be the correct answer, right? Then I went 506 plus 608, divided by 2, and so on. 506 plus 585, divide by 2. Now I'm done with 506. He's not going to be invited to the party anymore. I take 631 plus 549, divide those two by 2, and find it down here. 631 plus 608, divide by 2. Seems like a lot, but there's only 10. Okay, it's only going to be 10 numbers that I find. Then I have to go and find where they can be matched with replacement. So 506 can be teamed up with himself. So I had to find 506, 506, and then obviously an average of 506. Those are the easiest ones to find. You don't have to do any calculation. Just 585, 585, 585, 549, 549, 549, and so on. So that's your sampling distribution of all possible samples of size 2 with replacement. Oops, I probably missed one somewhere in there. Okay, I think the issue here is like I didn't even look at this one. 506, 631. I think I selected 631, 506, for example. To me, that's the same example, but it's the same sample. But they're looking at the order as important. So it would have to be, since 506 comes in the list first, put 506, 631, not 631, 506. A little bizarre. The mean of the sampling distribution, though, is going to be real simple. That's going to be 575.8. I don't have to do any work for that. Okay, it's the mean of the population. That's our central limit. Standard deviation of the sampling distribution, we're just going to take that 44.18 and divide it by the square root of 2. And we round to 2 decimal places, I think, so that'd be 31.24. Okay, so that's all we're looking for. I'll leave the multiple choice comparisons for you to finish there. Let me take a look at number 11. I hope it's not like that one. I want to do another one of those. Yes, I want to leave. Okay, so this is a little bit different. That's why I wanted to look at this one. The population mean and standard deviation are given below. So this is going to bring normal CDF into play for us. Okay, so the population mean and standard deviation are given. Find the indicated probability and determine whether sample mean in the given range would be considered unusual. So remember, something unusual would be beyond 2 standard deviations above to 2 standard deviations below. So for a sample of n equals 34, find the probability of the sample mean being less than 12,752 or greater than 12,755. And then they give us our mean and standard deviation. So let me look at my whiteboard for this because I'll lose track of these numbers. But my limits are 12,752. So below that or above 12,755. And then we know that our mean is 12,752. So I can kind of tell already this is not going to be unusual. If the mean is 12,752, below 12,752 is not going to be unusual. That's going to be 50% of all observations. And then the standard deviation is going to be 1.3. But that's not the standard deviation we're going to use. We're taking samples of size 34. So we're going to have to use this standard deviation. Okay? So I want to try to picture a normal curve. I know that 1272 lives in the middle. Now, this first part here, I don't even need my calculator for. I know the probability that something falls below 12,752 is going to be 50%. Okay? So that's definitely not unusual. And now the 12,755, that's going to be up here. We're going to go back to normal CDF, which we left off in the last chapter, or our last test. 12,755 is my lower limit. Then pick something really big as your upper limit, like let's say 100,000. Okay, we don't even need to make something that big, but I'll put it in there. The mean is 12,752. And then my standard deviation is that 1.3 over root 34. Like previously, we didn't divide by the square root of 34. Now we have sampling distribution situation, so we would need to. I'll use my calculator for this. It's normal CDF. Put something really high here. The mean was 127,752. And our standard deviation is going to be really small. It's going to be 1.3 divided by square root of 34. And again, if your screen doesn't look like mine, that's okay. Don't panic. It'll look like this, right? You put in your lower limit, your upper limit, just separate everything with commas like we did in the last chapter. So that is really unusual. That's going to be a really, really small number. See how it's 1.475 times 10 to the negative 41st. So I don't know if they're asking me this in two questions, but less than 12,752 or greater than 12,755 is just going to be 0.5. Okay, it's just that one area to the left, the area to the right of the 12,755. So that would not be unusual. Now, something out here, this is unusual. This is our value that we got that was really close to 0. This is something that happens 50% of the time. So they kind of gave us two questions at once in that, but the overall answer there is that it's not unusual if it happens 50% of the time. If it happens, generally our rule of thumb is if it happens more than 5% of the time, we're going to say it's not really unusual. It's not going to be too eyebrow-raising for us. Okay, so question 13, I will leave this question, that's fine. Okay, find the probability and interpret the results. Okay, use technology. Population mean is 61,000. Random sample of 33 is drawn. What's the probability that the mean sample is less than 58,000? And they give us the standard deviation of 6,300 for the population. So this is going to be a normal CDF problem again. All right, I have a mean of 61,000. I'm going to put that in the middle here. And recall, I'm going to take a sample of 33, so the standard deviation is going to be smaller. What's the probability that the sample mean salary is less than 58,000? Again, I might not be drawing my areas very accurately, but that's okay. We're going to do normal CDF to figure out what it really is. So we would have normal CDF. We'll go 0 to, let's say, 58,000. You want to put negative infinity in there, that's fine. So lower limit 0, upper limit 58,000. The mean is going to be 61,000. Okay, and then the standard deviation, it's not 6,300. In the last section, it was real easy. We just throw in 6,300. Now I have to take that and divide by the square root of 33. Okay, so we throw that in the calculator and see what we get. Just hit second enter if I want. Might be quicker, just put in normal CDF. This calculator will freeze on me if I click this button too rapidly, so that would be not fun if our calculator freezes. Okay, so we started with 0 as our lower limit, and then I think it was 58,000. The mean was 61,000. And I did not calculate the standard deviation. I'm going to let the calculator do that for me. But it's going to be 6,300 divided by root 33. Oops, I missed a comma somewhere. Oh yeah, I'm missing. Oh, I got all kinds of stuff out here that need to be deleted. So we want to finish here and delete all that. .003. 4 decimal places. .0031. So that would about 31%. No, it's 0.31%, right? 0.0031 is 0.31% if we convert that to a decimal. Okay, so this question is just simply conceptual. Well, they do ask us the probability, but this is a central limit theorem question, right? What's more likely, to get one woman with a height less than 65.9 or to get a sample of 18 women so that their average height is less than 65.9? So the mean of the sampling distribution is 64.2, okay? So a height less than 65.9, what's going to happen here, since 65.9 lives up above 64.2, when we take 18 women at a time, their average heights are going to tend to be closer to the 65.9. But this one will let us, we can kind of go through and do the computation, and we'll compartmentalize this one. What's the probability we select one woman with a height less than 65.9? So here we just use our parameters. We use the 64.2 and the 2.3, and it's a simple normal CDF problem like we did in the last section. So we have normal CDF. We want the probability that her height, just one woman, is less than 65.9. So our parameters would go from, let's say, 0 to 65.9. Right? This is the probability her height's less than 65.9. And it's just one woman, though. So since we have a normal distribution, we can do that. The mean is 64.2, and standard deviation is 2.3. Okay, so I get 0.77. See how many decimal places they want. 4. All right, so lots of women are going to be less than 65.9. All right, now we're going to take 18 women's heights at a time and average them. So the only difference here, I'm going to change one thing. When I hit second enter, I do everything the same except my standard deviation is no longer 2.3. It's now 2.3 divided by the square root of 18. Okay? The standard deviation is going to be smaller. The heights of 18 women at a time are going to tend to be closer to, I don't know if it's going to like that extra parenthesis there. Let's see. Delete that. Get out. Yeah, there we go. So we have to take that 2.3 and divide it by root 18, so we'll get a much larger probability, right? It's taking 18 women at a time. Their average height is going to tend to be a lot closer to the mean, so 0.9991. Okay, so I hope that's a helpful little sampling of what you'll see in your assignment this week.